Hello, and a very warm welcome to a very warm Tuesday and another oceanographic roundtable discussion. It's lovely to have you all with us once again online for this event. This is, of course, the latest in our ongoing series of oceanographic roundtable events. For those of you still keeping track of just how many roundtable sessions we have hosted until now, you are all doing far better than I am because I lost count a long time ago. But suffice to say that all of our previous roundtable discussions are available to watch back on demand via the Oceanographic website or to enjoy in podcast format across both Spotify and Apple Podcasts. These roundtable discussions are a chance each week for oceanographic audiences from around the world to join us as we dissect and dive into some of the biggest headlines across the ocean news and ocean storytelling space. Now, already in this series of live discussions, we have most recently tackled the topics of the effectiveness of marine protected areas, the issues around unregulated and illegal fishing, and latterly, the critical issue of fin whaling in Iceland, as well as the severe overfishing crisis here in UK waters. We have also dissected the biggest announcements to come out of the Our Ocean conference and taken the opportunity to celebrate some mega ocean wins, including shining a spotlight on the conservation and recovery projects taking place along the Sussex coastline here in the UK. So we have been able to, over the course of these discussions, table some of the happier conversations here on the roundtable too. The story we are here to discuss this week is one of the most consequential unfolding in ocean and climate science right now, and it is happening in one of the most remote and extraordinary places on Earth, because Greenland's glaciers are melting. Not slowly, but at an accelerated rate, that is, adding vast quantities of cold, fresh water into the North Atlantic at a pace that is beginning to concern scientists. The question this raises, and the question that is at the heart of today's discussion, is what that means for the ocean systems that regulate our climate and how close we might be to a point of no return. At the center of that question is a remarkable planetary system called the Atlantic Meridional Overturning Circulation, or the AMOC for short, often thought of as the planet's ocean conveyor belt. It's a vast three-dimensional system of currents that moves heat, nutrients, and energy around the world and keeps northwestern Europe significantly warmer than its latitude would otherwise allow. The AMOC is driven by the sinking of a warm, salty water as it reaches the North Atlantic and cools. But as Greenland's meltwater pours into the ocean, it creates a layer of cold, fresh water that could prevent that sinking from happening, slowing or disrupting the circulation system that billions of people depend on for the climate they live in. All of this is precisely why a team of international researchers has just set sail for Greenland aboard the RRS Sir David Attenborough as part of the giant project, Greenland Ice Sheet to Atlantic Tipping Points. Over 6 weeks, they will deploy a fleet of scientific instruments, including robots, drones, satellites, and sensors to measure glacier-ocean interactions at a level of detail that has never before been possible. Among them is Boat Team at Boatface, the National Oceanography Centre's auto-sub long range, which will dive to 1,500 meters beneath the ice to map the geometry of the ice melange and study how it shapes the ocean around it. The data gathered will feed directly into the next generation of climate models and potentially into the world's first early warning system for rapid glacier change. Today's roundtable brings together two scientists who understand this world intimately, one from the perspective of ocean modeling and climate dynamics, the other from years of direct experience on the ground and on the water in Greenland itself. Because today I am, of course, joined by Dr. Alice Marzocchi. Dr. Alice Marzocchi is an oceanographer and climate scientist working at the National Oceanography Centre since 2018. Her research combines numerical models of varying complexity and resolution with observations to better understand past and present climate dynamics and simulate how these may change in the future. She is especially interested in the role played by the ocean in the climate system, with a focus on high latitude processes, large-scale ocean circulation, ocean sea ice interactions, ocean carbon uptake, and always striving for a multidisciplinary approach. This includes the use of the autonomous platforms such as the AutoSub Long Range. Within the ARIA Forecasting Tipping Points program, she is the NOC lead for the Polemics project and co-lead on the Aerostats project, which are investigating ocean mixing and small-scale processes in the subpolar North Atlantic and Greenland sea ice margin and the potential for future tipping points. Big breath there from me. Alice, so thank you so much for joining us this afternoon for this conversation.
Yeah, hello, thank you. It's great to be here.
Good. Thank you for being us. Thank you for joining us. We are, of course, also joined by Sharon Gray, Associate Director of Rising Seas Institute, part of the Nova Southeastern University of Florida. Sharon is a marine scientist and science communication specialist whose career has taken her from government research agencies and aquariums to the ice sheets of Greenland, and most recently to life aboard a catamaran, where she and her family experience firsthand and real-time impacts of climate change on marine ecosystems and coastal communities. She holds degrees in biology, chemistry, and psychology alongside a technical degree in marine environmental technology and advanced scuba diving certifications, and has spent more than a decade translating complex climate science into accessible public education through writing, public engagement, and the development of curriculum for undergraduate and graduate programs. Oh, Sharon, another deep breath over here. Sharon, thank you so much for joining us this afternoon.
Yeah, thank you for having me.
Oh, great. No, it's absolute pleasure. And with such a lineup, I have full confidence that we are in for an in-depth and insightful discussion around this very pressing topic. I am, by the way, Rob Hutchins, community editor here at Oceanographic, and my role here is to be asking all of the questions. But to make it easier on me, do, throughout the course of this discussion, post your questions for the panel into the chat, and I will endeavour to get as many of those answered for you as possible over the course of the next 30 minutes. Right. Those introductions are made. Thank you all for joining us. I am really going to get my breath back now, and let's jump into that conversation. Let's start with you, Alice. And actually, why don't you just paint us a picture as to why we're talking about Greenland, the importance of Greenland.
Oh, I don't know if I am the best one to talk about Greenland. That might be Sharon, but I guess from the perspective of the ocean, as we were discussing, if we're interested in the amount of fresh water that is reaching the ocean in the subpolar North Atlantic, obviously Greenland holds a lot of this fresh water into its ice sheet. And yes, so Sharon might actually want to say something more about Greenland itself, because I think that's where I might stop for now.
Okay, well, let's kick off there then, Sharon. Maybe you could illuminate as to why, in this context, are we talking about Greenland? What's making it so important a focus of conversation right now?
The importance of Greenland is the rate at which it's melting. And it holds about 7 meters of potential sea level rise if all of it were to melt, which isn't expected this century, but will potentially happen. So that's going to affect coastlines all around the world. 140 nations have coastlines. So as the melting in Greenland accelerates, it's not only going to affect the ocean currents and which affects weather patterns and can affect, well, I don't want to get too far ahead of myself, but so it will raise sea levels, it will affect weather patterns, and it's on track to being the biggest contributor to sea level rise. We're almost there where it's the biggest contributor, so it's really important to watch.
Yeah, fantastic. Thank you for painting that picture, that broad picture. Then, and so Alice, let's turn to you then, and to talk about the AMOC. And for anyone who's joined us that may never have heard of the AMOC before, can you paint the picture then of what this system does and why scientists talk about it in terms of tipping points rather than gradual change? Yeah,
so you've already given a good introduction to the AMOC in your own intro, but I guess to summarize, we can talk about the AMOC. It's often referred to as a conveyor belt because it's this large system of currents which is basically transporting heat northward into the North Atlantic. And as you also mentioned, is what is keeping our climate in the UK and some of Western Europe milder if we compare to the same latitudes on the other side of the Atlantic. It's because of these northward heat transport that is coming up with the surface branch of the AMOC. When these warmer waters, saltier because they're coming from the subtropics, reach the subpolar North Atlantic, here they need colder air temperatures, and so they cool. And thanks to their temperature and salinity, they reach a density that allows them to sink to deeper depths, and then they flow southward at higher depth. And this is what kind of sets into motion this conveyor belt that we've been discussing. And when we talk about this in terms of tipping points, I mean, the tipping point for the AMOC would be, is it going to shut down? That is really the key tipping point. Personally, I think that is maybe not necessarily always the immediate right question to answer, just because before we could even potentially get to this tipping point, there will be a lot of gradual change on the way that is still going to influence weather patterns and a lot of other things that Sharon also mentioned. So the tipping point itself would be if you've seen the movie The Day After Tomorrow, that one is the tipping point scenario. That's the AMOC that stops to function. And so this conveyor belt and heat moving around is not happening anymore. But even before that happens, that gradual change is still important to think about.
No, thank you. Thank you so much. And actually, shall we address the elephant in the room and address these soaring temperatures that we're experiencing right now in the UK? Because I know that we had this little preamble before we went live. As the questions that you get asked all the time is, are we experiencing the impact of a weakening AMOC right now with the climate, with the heat wave that we're experiencing? Is that anything to do with what we're talking about right now?
So I guess connecting directly this heat wave with changes in the AMOC would be a bit of a stretch. Also, in a way, it's slightly counterintuitive, because what we know, if we're thinking of a shutdown of the AMOC and a tipping point scenario, what would actually happen for the Northern Hemisphere is that on average, temperatures would cool. So in reality, we might experience fewer heat waves in that scenario. But we're definitely not in that scenario yet. So in this kind of transition period, it's a mix of whatever could be happening to the AMOC and the background of global warming. And what this is doing, it's affecting some of the weather patterns, those that cross the Atlantic. So we have storm tracks, the position of the jet stream, and heat waves are one of those extreme events that in this climate change scenario could become more intense, more frequent, harder to predict in the future. So I guess that's probably as far as I can go as connecting it to the AMOC.
Okay, well, there you go. There, note taken. Stop asking you whether heat waves are anything to do with AMOC right now. So turning to you, Sharon, and to talk about your experience, because obviously we had a little preamble talk before coming live as well, and actually to draw attention to that amazing backdrop that you're sat in front of. That is a photo that you've taken of a glacier on Greenland. So I'm going to ask you about the fact that you've led multiple expeditions to Greenland. What does ice sheets retreat actually look like on the ground in ways that don't always come through in data or headlines?
I think that the biggest thing that doesn't come through is just the scale, just how massive the ice sheet is, and I mean icebergs can be the size of buildings. The glacier that's in the picture behind me, this is Jakobshavn Glacier, and it's the most active glacier in Greenland. And that glacier front, I keep trying to point to it with my pointer, and you guys can't see that. Sorry. It's 200 meters tall. I mean, it's just massive amounts of ice, and that's just one of hundreds of glaciers. So the scale is something that just never translates in photos or in videos. And then the melting itself is I was kind of saying this before the official talk started. The second time I ever went to Greenland, I was very curious if I would be able to just with my own eyes just visually see the difference from the year before, thinking certainly not. And I could. It was kind of alarming. I could actually tell the difference just in the height of this glacier, the amount of meltwater pools. Those seem to be increasing. And then the calving events, the ice actually breaking off from the glacier front. Every year, there's just more and more of those events. The very first year I saw one while I was there, and now it's multiple in an hour. It's just the rate is just increasing pretty dramatically, and more quickly certainly than the models are capturing.
Interesting.
So
that's really interesting.
That's where it's important to have people on the ground, just to be matching up with the projections versus what we're really seeing.
Yes, absolutely. And a really good point, and a really good point to actually turn the next question to you, Alice. And obviously your work combines models with observations. What are current models telling us about how sensitive the AMOC is to the volume of fresh water coming off of Greenland, and where are the biggest uncertainties right now?
Yeah, so that's a good question. And unfortunately, the answer is that is one of the hardest problems for the numerical models, especially because most of them don't actually have interactive ice sheets. So this melting doesn't actually go directly into the model. The issue with numerical modeling is it's a big trade-off of, do you want to represent all of the possible processes all at the same time, land, atmosphere, ocean, biogeochemistry, or, do you want to look at the small scales? And with the computing power we have, we can't do all of that. So when we want to have all of those processes together, we don't have really high spatial resolution, meaning that we miss some of these important processes. But ice sheets is actually one of the hardest part of the coupling. And so those models that contribute, for example, to IPCC, the Intergovernmental Panel on Climate Change, that gives us these projections for the future, the majority of them don't actually have ice sheets. So the way that this freshwater input is treated is normally done with some kind of sensitivity experiments, which are not so easy to replicate because you might end up putting that fresh water in the wrong place. You might be putting too much of it all in one place and it doesn't spread in a very realistic way. So we know that the models are sensitive to these changes, but it's difficult to actually do it all in a kind of holistic simulation and really just trust that prediction because it's difficult.
Yeah. No, I can imagine. Yeah, and so that sticking with you then for a bit, then Alice, the Giant project is now deploying in this unprecedented level of instrumentation, including boating with boat face, which will be diving beneath that ice. What specific gap in our understanding is that data meant to fill that satellites and those existing models can't quite capture?
Yeah, so these instruments, first of all, will be able to get really close, for example, to the face of the glacier. So those are kind of new measurements, especially with so many different instruments all at the same time that we haven't had yet, mostly because the technology is just evolving really quickly. So we're kind of just getting there now. At the same time, satellites will only be able, for the most part, just capture the surface of the ocean, whereas we have BOTI and other instruments that will actually go beneath the surface, map the face of the glacier and other elements that we could never see from satellites. And again, all these kind of small scale, both in terms of space and time observations that we're getting should hopefully help us understand those processes that might not be represented in the models yet, but by getting a better understanding of them, that's kind of the ultimate aim.
Yeah, wonderful. Thank you so much. And I'm just seeing this question from James pop into the chat. So I'll ask this one. Do we know how more quickly the melting is actually happening compared to the climate models, such as 30 meters per hour compared to 15 meters per hour? Has modeling taken into account the freshwater taking time to mix with salinity and the physics of this? If so, how do the models do this? How does the albedo effect accelerate the melting of glaciers? I think there's about 13 questions in one now. I don't know, Alice, do you want to pick any of those to unpick?
So I guess I am not a glaciologist, and so the kind of modeling I do is not so much of the glaciers or of the ice sheet as itself. But so the models will take into account the fresh water entering. So the way it will mix and change the salinity is taken into account. This is why you can see in the models that an excess of fresh water can impact the sinking of those deep waters. So sometimes it's done through parametrizations that are introduced in the models simply because, as I said, the resolution is not high enough. So whatever process you can't resolve directly, there will be some set of equations that is basically representing that process.
Yeah. Interesting. Thank you. And Sharon, is there anything that in there that you might want to weigh in on and unpick or help us unpick?
Sure. Yeah. I guess the two comments, and I'm not a modeler, so as far as how quickly the melting's happening compared to the models, actually glaciologist Jason Box works with us, and one thing, he's been studying the Greenland ice sheet for 30 years, and what he's told me is that the melt that we're seeing on the ground wasn't predicted by the models to happen for 40 more years. So it's happening in a much quicker pace than the models are able to show. And then for the albedo, I mean, yeah, as sea ice melts, the oceans absorb more heat, which, warmer water melts the glaciers from underneath. And then there's also particulate matter and algae and things that will lessen the albedo effect on top of the ice, which can then that ice itself is absorbing more heat.
No, yeah, thank you for painting that picture. And actually, since we're with you, Sharon, maybe we go back into those on the ground sort of observations that you've been privileged to over the last however many years that you've been going over to Greenland. So obviously now you live aboard a catamaran with your family, and you're experiencing those climate impacts firsthand and on coastal communities. What changes have you personally witnessed that most surprised you?
So the sea level rise itself, because we're floating, it doesn't affect us quite as much on the boat. I've seen in the neighboring communities things like sunny day flooding, which is when we get flooding from either a high monthly high tide or king tides, which are exceptionally high tides throughout the year. They're now flooding neighborhoods that didn't used to flood. It's called sunny day flooding because you're flooding, but there's no rain. There's, the sun can be out, but you're actually flooding from underneath. So as sea levels rise, that it kind of raises that baseline from where the high tides, then raise when it's high tide. And so some neighborhoods are starting to be flooded even once a month in parts of South Florida. Another thing I'm seeing is kind of the intensity of hurricanes increasing. Particular, I'm on the west coast of Florida, and where I live, we didn't really used to get hurricanes. There was, we're just sort of in this little protected area between the way the wind currents and the ocean currents work here. And now we're sometimes evacuating 2 and 3 times a year, largely from storms that are popping up in the Caribbean or in the Gulf of Mexico from the increased sea surface temperatures. Partially, not entirely, but it does affect, how storms develop and how they intensify. So these, as the surface waters keep warming, we're seeing more rain, more storms, more intense hurricanes. And yeah, these are all things it's affecting for the communities here. I'm seeing the homeowners insurance is being affected. People, I get asked all the time, when should I sell my house? When do I need to move? So it's on a lot of people's minds, and particularly where I live.
Yeah, real world impacts that actually you overlook that just those people living at the front line of be experiencing. So actually, to ask you this one, then I think that leads quite nicely into this. Having worked at NOAA, Moat Marine, Monterey Bay Aquarium, and within university teaching, you've obviously spent years translating those complex science, for many non-specialists. What is the hardest part of communicating something as abstract as ocean circulation collapse, or to people that don't see the ocean every day?
Oh, there's a lot of hard parts to it. I think that one of the hardest things is how we communicate uncertainties. I think a lot of people don't understand that uncertainty is sort of part of the process of science, and they take it to mean that we, there's a lack of knowledge or a lack of reliability, instead of that uncertainties are sort of baked into the process. And so, for instance, when I get questions like, when should I sell my house, or how high will it be by 2050, or people don't like I can't answer that. We don't actually, there's no way to know it'll be, sea level will be this high at this year. so that those uncertainties then translate. It's hard to translate to people in a way that doesn't make them feel like, okay, well, why are we paying any attention to what the scientists are saying if you don't know anything? So that's a really, really challenging aspect of it. And the other big challenge is just people's emotions are really involved in this subject. It's really, nobody wants to hear kind of the worst case scenarios. They really, get emotional. The cognitive dissonance kind of sets in where they want to look away from it. Or on the opposite end of that, people get massive amounts of anxiety and don't know how to handle that. So the navigating just people's emotional states with really tricky subjects, it has always been very challenging.
Yeah, I can imagine, and I can imagine that challenge is even greater when you look at some of the actions taken perhaps by the current administration over there in the US and the approach to climate science and observation science. And I'm going to steal Leslie's question here from her, and I'm going to ask you about how essential to international modelling efforts, including data from ocean sensor systems, are the US's contributions to these tools, which we know are at risk. Obviously, knowing why Leslie is asking this question, what are your thoughts on that, Sharon?
So as far as for international modeling, I mean, my understanding of this is there a lot of them are essential, especially the NOAA, the ocean sensors and those systems, which were at risk there for a minute of being completely removed. I think the administration's reversed on that, luckily. But even some of the weather balloons that we used to send out to track hurricane formation and things like that, they're not getting sent up. At least not as many as we should be. So that's, I don't know yet how that's going to play out with this coming hurricane season. But I suspect it's not going to be a good thing that we have less data to drive the models and predict what storms are going to do, what ocean currents are going to do. Yeah, it's it's a distressing subject for really for everybody, but particularly for us in the US. It's something that I'm hoping changes soon. Yeah.
No, and I appreciate you sharing that as well. Thank you. Alice, to bring this back to your line of work and to your area of expertise and some of these projects that you're working across, including the polemics and the aerostats project, looking at these small-scale mixing processes. Why does something as seemingly minor as ocean mixing matter so much when we're talking about planetary scale circulation systems? If you could just paint us a picture of that scenario for us.
Yeah, so I think in a way this actually links back to the question that Sharon was just answering, because for the pole mix project, actually the main instrument that we're using are called Argo floats. So it's this big array of floats that are deployed in the ocean. They're relatively easy to deploy, but they take really important measurements such as temperature, salinity, oxygen, and other elements. But a lot of this array up until now has been maintained by the US. And so the situation is also distressing for us, because moving into the future, we don't know which other countries will kind of chip in to, potentially cover all the floats that the US might stop deploying. So yeah, and these really contribute to weather forecasts as well. So they are really important floats. And so, for example, in pole mix, we are deploying as part of these floats, they have a probe that measures this small scale mixing. And the mixing is really important because, as we've been already discussing, that is kind of that process that allows the waters to reach the right density, bringing salty waters from the subtropics up to the subpolar gyre, and reaching the required density for deep water formation. So it's something small, and that is what makes it difficult to both observe and to represent in numerical models. So a numerical model that doesn't have a high enough resolution will not have a really good representation of mixing. So our understanding of it can't really just come from models. And at the same time, we don't have a lot of these instruments that can measure them in the ocean directly. And so our understanding is limited in this way. So it's a small process, but it's quite an important one. And so we need more observations. And the same kind of probe is also on BOTI for the giant mission. So they will also be measuring this small scale mixing near the glacier and under the melange.
Melange, that's how you pronounce it. I was wondering how you pronounced it. I said melange. I think I put a bit of an exotic twist on it. But thanks so much. I'm just watching the comments and the questions coming in. I think we've got some really great engagement, really great questions here as well. And I want to ask this one about from Medea, about who grew up in Venice, Florida, and spent a ton of time at Moat. And the change in climate is drastic. I wonder what the people of Greenland think of the increase in Kelvin of the glaciers. Are there glaciologists with whom you work there? And I think that's one for you, Sharon.
Yeah, we do work with, it's interesting, there aren't really any that I know of, certainly not very many, if there are any Greenlandic native glaciologists, but there are many, many Danish glaciologists who work in Greenland, and we have US glaciologists there. So we work with quite a few. As far as what the Greenlandic people think of the calving and the melting, they're, and I always hesitate. I don't want to put words in the mouths of another culture. But from the people I've spoken to, they're hyper aware of nature there. Their culture is just very, very connected with the ice and nature. So they're super aware of what's happening, and how it's, there's changes to their fisheries there, which is a really, really important economic and just for, survival aspect. There's things like where I spend a lot of time in Ilulissat on the west coast of Greenland. And there's an island off the coast there called Disco Island. And it used to be in the winter, you could sled, they still do dog sleds in the winter. You could sled from Ilulissat to Disco Island. And now the sea ice is too unstable to do that anymore. So there's lots of ways that their kind of traditional way of life is being impacted. And then there's potential benefits as the ice sheet melts and more land is exposed. There could be more opportunities to actually grow food that they haven't had. They kind of primarily had to use greenhouses and a few areas where some wild berries and things like that grow. And sea levels actually, interestingly enough, not rising in Greenland because of as the ice sheet melts, the weight is less, so that there's this isostatic rebound of the land, so the land actually rises. So they're not as at risk from the sea level rise. And this could be good or bad depending on your stance, but it does open up land to drilling for minerals and things that if done the way they want it to be done, then could be an economic benefit to them. So it's very much a mixed bag. I guess the best answer to your question is that they're super aware of it. They're paying close attention to it, and we'll kind of have to see how much of a benefit there is, or if it's largely negative, like it's going to be in most places.
They're so interesting to hear, and obviously, we see this in the news and we see the headlines as well about. And Greenland's been such a focal point of many news stories and advise across the geopolitical landscape. And I guess what we're facing is just this massive shift in norms and realities for people, globally, but especially there on Greenland as well. So Alice, I was going to ask you then, what would you want a policymaker to take away from the research that's going on in Greenland right now, or the research that you've been across? Is there a piece of evidence or a threshold that, if crossed, should really change how urgently this is all treated?
So I think the problem with tipping points is that if we really started to approach one, it might potentially even be quite late to act on it. So what policymakers need to be aware quite early on is about any adaptation measures and things that we might need to do in response. So that part is really important, and it's not something that you can leave to later, because if you're talking about how you're building your infrastructure, well, you need to start thinking about it now, not maybe in 50 years' time. I don't know if there's a single threshold that we could pinpoint. Probably for the AMOC, it would be a multi-threshold of different elements. But what the giant project is trying to do, for example, is if you start sort of upstream and look at the glaciers, if you could identify some really key changes in the glacier melting and then try to act on it before you see more changes downstream, that could be one way to look at it. But ultimately, I think the point is, let's not just focus on the tipping point, because the ongoing changes that are already happening now is what is important and is what we should not just be distracted from, because obviously there's lots of stuff going on in the world. There's not just climate, but we should not get distracted from this key problem.
Yeah, no, absolutely. And just on that tipping point, are we talking decades, or are we talking something faster than that?
I mean, we don't have the answer to that because obviously we have models, different climate scenarios. So the answer depends on a lot of elements. And from the observations point of view, we just need to continue these. We don't have long enough records to give it definite answers. Yes, some models do point to like significant changes that could happen in the next few decades. So I guess that's probably the part that we should focus on, because even a, say, 30% decline in the AMOC, which is what is maybe projected by some models, would be a really important effect and impact to consider.
Yeah. No, absolutely. I just wondered, as you were describing that, I wondered if there was a moment in your own research where you've had it where a result has genuinely surprised you, or it's sort of overturned what you were expecting to find about the AMOC or about Greenland's ice-ocean interactions more generally.
I don't know. I think from the modeling perspective, it's just really complex. So, obviously we know that looking just at one single model, we might get an answer that seems, oh my God, I can now predict with this certainty that this event is happening. But then we need to consider that can't just be the one answer. We need to consider other models. We need to consider all of the uncertainties. So probably the more you work on it, the less you believe on it. I think there's actually a saying that says, nobody believes in the models, in numerical models, apart from the person who ran them. Whereas for observations, it's the opposite. Everybody believes in the observations apart from the person who took them. And this just means that, if you took those observations, what all the potential errors that come with it. And at the same time, and whereas with models, everybody's automatically skeptical about them. So it's like a strange mix of who trusts what better.
Yeah. Yeah.
In reality, sorry, I was just going to say, in reality, I think the more is not necessarily related to the AMOC, but the most striking change I've ever seen is probably just from my experience as a scuba diver. I think, I don't know, things that are way more visible, such as coral bleaching, like Sharon was saying, going back to the same place maybe 5 years later and knowing there were corals and they're not there anymore. So I like my holidays warm, but I guess my work always takes me to cool places. So maybe that was an easier example to think about.
Yeah. Oh, great. So I've just seen this another question coming from James, and I think there's some very good points here. How much of the obvious uncertainty in future sea level rise comes from not understanding glacier physics versus not knowing future greenhouse gas emissions? It seems politicians and countries with beaches only act when it's too late as an emergency. So it's important for climate experts to have more certainty. Can AI help? How and can AI help and more sensors perhaps? I don't know. Anyone want to field that one? Again, James, there's thousands of questions in there. I guess if we boil it down, how much of the uncertainty around future sea level rise comes from not understanding glacier physics versus not knowing future greenhouse gas emissions?
I mean, I would say both are heavily involved. The models, I think this has been discussed already, but the models aren't great with some really complex processes and abrupt changes and things like that are just part of how glaciers melt. But then, yeah, it's if you don't have the inputs to put into the models, if you can't say this is what our future emissions are going to be, then it's all estimates. So I'm probably not as well equipped as Alice to answer which is most important in the models, but from my perspective, they're both super important, and there's not a lot you can do about not knowing future emissions.
No, absolutely. Yeah, I think you're right there. Sharon, actually, I wanted to ask you this one, because obviously you've moved between some very different worlds, government research, aquariums, the university teaching, and now you live aboard your catamaran. Which of these experiences has shaped your view of what we're facing, whether it's a crisis or that crisis the most?
I mean, I think, I don't know that I can say one has the most. I think actually having a really broad background has helped me to understand, because these are all, systems, processes, and everything's really interconnected. And so I think having a broad background like that has helped me to see how things connect better than if I had kind of narrow focused on one area. So I mean, being on the ground in Greenland definitely puts things into perspective as far as I said before, the scale of really what we're dealing with. And then, living on the catamaran is really more of like I kind of joke about it, but it's a bit of a prepper plan, like, okay, well, let's make sure we float and we can create our own energy and make our own water, that kind of thing. So yeah, I don't know that anyone has informed more than the other. I think they've really all played a part.
Yeah, of course. And I'm I'm totally aware of time and wrapping things up. And Alice, I know that we're quite ironically melting ourselves in this heat wave that we're all experiencing in the UK right now. But I do want to ask this one from Beatrice, because I think it does leave on a quite a poignant note. But are there global targets and measures for sea level rise in a way that climate change has?
So I guess I'm inclined to pass sea level rise to Sharon, but I guess the targets that are set, for example, to limiting to 1.5 degrees of global warming, that will connect directly to the amount of sea level rise that you get for that amount of warming. So I think that's how basically the targets connect, but I don't think they're set directly in terms of sea level rise, but Sharon can correct me if I'm wrong.
There's a few groups that are trying to kind of establish a target. It doesn't really make a lot of sense to me, because exactly as Alice just said, it's tied to warming. So you can't say, oh, let's cap sea level rise at a meter, but do nothing about emissions or warming. It doesn't work that way. So I think it's really more for kind of communication purposes than actual policy or anything actionable. But an important thing to note too is, even if we could stop all emissions right now and stop the warming where it is, we've 93% of the excess heat is stored in the ocean. So we've already warmed the ocean to the point that sea level will continue to rise for centuries, even if we stopped all emissions right now. So now, stopping emissions and slowing the warming will slow the rate and slow the ultimate amount that it rises, but there's some level of sea level rise that's baked in. So and kind of actually what Alice was saying about the policy suggestions, there's a level that we're going to need to prepare for adaptation wise, no matter what. So as far as the original question of targets and measures for sea level rise, it's I guess the long-winded answer I was giving is no, there really aren't, and there really can't be in the same way. We can look back at the paleo record to see how much sea level rise we get with certain amounts of warming, and it's like 20 meters per degree Celsius is what the paleo record shows. Eventually that's how much sea level rise you get per warming, and we've warmed just about 1.5 already. So there's an amount that's locked in, and saying let's target at this level, it just doesn't work because we've already put that heat in the ocean.
Yeah, that feels like a bombshell, and I don't really want to end on a bombshell. I'd like to end on a note of hope and positivity. I wonder if there is something we can find here to be hopeful, or what gives you that hope when you're working across these various projects that you are, and when you're seeing these things in real time, Sharon, and when you're working across the models that you are, Alice. Sharon, what's giving you hope right now?
Yeah, so I get asked this question every time because the subject is so heavy, and I always say, like, I wouldn't be doing what I'm doing if I didn't have hope. And really, for me personally, I kind of, hope is more like an action verb, like, there has to be some action behind it. And where I derive the most hope is sort of the ingenuity of humans. When we actually pool our knowledge and pool our resources, we can come up with some pretty amazing solutions. So that's kind of where I'm getting the most hope, is that we'll do that more. We're doing that some, but if we do that more, we can actually come up with some pretty interesting solutions to these problems.
Totally agree. I like that. That's lifted my spirits somewhat. Alice, bring it home for us. Give us a note of hope yourself then for what you're working across and what keeps you hopeful.
I think my answer was also going to be similar. So one of the things that I enjoyed the most, a bit like Sharon said, is working across different disciplines and with people who are experts of a lot of different things. And then when you put it all together, that's where you start unlocking some of the changes. And I think that technological advancements are also giving us hope, like these measurements that we discussed, just maybe 5 years ago would have not been possible. So yeah, I think putting all of this together, these really strong international efforts, let's forget for a second about the negative aspects that we discussed, but we are still doing a lot of international work together. And I think it's hopefully moving us in the right direction.
No, I agree with both of those sentiments, and it's so buoyant as well. And it does lift my spirits. Genuinely, it does when you see that there are some absolutely brilliant minds working across these things, and there's some really engaged and switched on people, two of which are with us this afternoon. And I thank you both for sharing that insight and that expertise and those stories that you have from your areas. But yeah, and that's very hope, and it gives a great deal of hope that we are working towards this collaboratively. So that long may that continue. Look, I'm so conscious of time. I don't want to take up any more of your afternoons and mornings. So I'm going to say thank you so much for all of your time and all of your energy and sharing those insights and expertise, answering all of those questions. Thank you to everyone that's tuned in for asking those questions. It's been really great to have those pop in throughout the discussion. And if you've enjoyed this roundtable session, be sure to come back next week when we will tackle the week's biggest story at the same time and the same place. And do check out the Oceanographic platform for the latest details on our live Ocean Talks events, as well as our printed magazine and everything else that we have to offer. So with all that said, that leaves me with nothing more to add other than have wonderful evenings and wonderful days. And thank you all so much, and see you hopefully next time.